So greetings students. So in today's lecture we'll be dealing with your problems with respect to your distributors. So we'll be seeing about AC distributor as well as your DC distributor. So starting with we'll be dealing with first your AC distributor. So first the problem states that a two-wire DC distributor, so length of 1 kilometer long, and it supplies a load of, so the following load currents are 90 amps, 70 amps, 50 amps, 40 amps. So they have given the distance between each load to be 200 meter, 600 meter, 900 meter, followed by 1000 meter. Okay, so from this occurs from your feeding point of your A. Okay, the resistance of the distributor they are given as 0.003 ohm per 100 meter length. So determine the voltage at each point. And the voltage at the point A is 220 volt. Okay, so here this is how the diagram looks like. So the diagram we have to devise it. So here the distance starting from A to B is 200, then B to C 400, then C to D 300. So here it is very clear that this type of load is a concentrated load. Okay, concentrated load distribution is given here. So here the resistance R is small r is given as 0.003 ohm. So it is given 0.003 ohm. So the resistance with respect to your RAB is your resistance into your length. So your length it is given as 200. So R is 0.003 ohm. So here this is divided by 100. The sense means, so we are converting your meter to kilometer calculation. Okay, so for that here divided by 100 is given. So we'll be making this, we'll be calculating for RAB, RBC, RCD and RDE. So these are the following things. So the current flow from A to B is nothing but the series connection. That is, you will be adding your currents from I1, I2, I3 and I4. So if you're adding means, so it will be around it is given the following currents are given 90 plus 70 plus 50. So from A into your sorry here not B, this will be across your E. Okay, from A to E it will be around 250 amps. Okay, so here sorry, it is A to B only. So A to B will be uh, here will be making all the currents additive. So when it is coming to a node, what happens is that the current gets splits up. Okay, so like that it goes on. So the additive current will be, the total current will be 250 amps from A to B. Then from B to C you have to subtract your I1. Okay, if you're subtracting your I1 means you'll be getting 160. That is nothing but 90 amps you will be subtracting from this. Then current flow through the section CD, you will be subtracting your I2. So you'll be getting 90 amps. Finally, DE will be of 40 amps. So for the voltage drop, it is nothing but I into R. The normal Ohm's law will be applying. So these are the voltages you will be getting. For the total voltage drop, you have to add all the things. So the total voltage drop will be around 4.35 volt. The voltage drop at point B, you have to subtract the voltage from A minus of your VAB. That is from the feeding point, you have to subtract the total voltage. That is across your AB. That is VAB. This voltage. So you'll be getting around 218.5. So next for VAC, you have to subtract your VAB minus VBC. Okay, similarly it goes on VAB plus VBC plus CD. Okay, so next we'll be coming to a DC two-wire system. DC two-wire system we'll be seeing. So this DC two-wire system will be of 200 meter long. But here the difference is that it is uniformly distributed, so it is a distributor load. So the load is distributed. So the resistance they have given is 0.2 for kilometer. So here they have given in kilometer. If the distributor is spread at one end, so it is the feeding point A. They ask to find your voltage drop up to a distance of 120 meter. Okay, the total distance is 20 meter, but they are asked only for your 120 meter from the beating point. Next is about they are asked your maximum voltage drop. They have asked maximum voltage drop. Okay, so these are the things they have asked. So we'll be getting to the problem. So the from the given it can take it as the current, the uniform current flowing through the entire distributed load I is 2.5 amp per meter. Next, the lambda, sorry, yeah, length L is they have given us 200 meter. So loop resistance R, how you can take it is twice the times of your normal resistance of the single wire. Okay, so here we are talking about two wires, so we'll be multiplying with that of the two time parameter. Okay, so now we are converting this into meters. So this is how it looks like. So next, the voltage drop at 120 meter. Why we are converting into meter means they have separately asked for a 120 meter distance. What is your voltage drop? Okay, so for that they had to convert this into meter. Okay, so here as per your problem, you have to convert to a meter or kilometer segment. You have to change. Okay, so here the voltage drop at 120 meter is IR into Lx minus x square by 2. So here 2.5 into 0.004. So here the length is 200 into x is 120. So this thing we have covered in your derivation. So here capital I equal to I into L, that is the total current flowing through the distributor load. So from this 2.5 you have to multiply with the distance, or you'll be getting around 500 amps. So similarly your resistance also, small r into L. So the maximum voltage drop is given by IR by 2. So here it will be, we have to apply, so you'll be getting 20 volt. Okay, the next problem is a DC two-wire system is 300 meter long, loop resistance they have given. Again we are coming with your distributor load. So calculate the point of minimum potential and the value of the potential when distributed from both the ends. So here comes the difference. The difference is that the feeding will be at the both the ends. Okay, so here it is very clear. At the B point also it is fed, at the A point also it is fed. Okay, so the minimum potential across the midpoint is L by 2, that is the total length 300 by 2. So you'll be getting 150 meter from either end. So the current equal to I into L, so I they have given. Okay, so L is 300. So the total current flowing through the distributor load will be 900 amps. The loop resistance they have given 0.064 ohm. So this 0.064 ohm they have not taken with respect to any kind of distance. Okay, so maximum voltage drop over here is for feeding at the both the end, it will be IR by 8. So 900 into 0.064 by 8. Okay, you'll be getting 7.2 volt. So for the minimum potential, you have to separate it from your so, so from your feeding point, any one of the feeding point you can take. So that is from 200 minus of IR by 8. Okay, so you'll be getting 212.8 volt. So the power losses are I square R by 12. So you have to apply, substitute the value, will be getting 4.32 kilowatt as your power loss. Okay. So next we'll be moving to the next problem. So the next problem we'll be dealing with a 3-wire DC distributor. So till now we have seen about 2-wire DC distributor, and now we will be dealing with your 3-wire DC distributor. Okay. So starting with so this is how it looks like. So there will be positive negative followed by positive negative. Okay. So this is also fed at one end between the wires and middle wire. Okay. So the voltage drop will be 200 volt. So over here it will be 220 volt, and again it will be from 220 volt. Okay. The numbers between the section indicate the resistance of the respective section. They have to calculate the voltage between the middle wire and outer at each load point. So that's what you have to calculate. Okay. And moving on. So you have to apply KCL and determine the current flowing through each section. Okay. You have to apply KCL. Okay. So here is one node, here is one node, here is one node, here is one node. So how it goes out you have to see. So voltage between the middle wire and outer wire is given by 220. 220 is what the voltage rise minus of IMA, that is from here to here, resistance current, into the resistance across this, plus here this ID, right? So ID O plus RDO. So here this point you can take it as a reference. So as a O, so IDO and plus your RDO. I will be making 220. The voltage rise minus of the voltage drop plus this voltage drop, because here you are applying KVL, right? So the voltage rise is equal to sum of the voltage drops. So we'll be getting around 217. So similarly, you have to apply for each and every loop. So you will be getting your voltage. Okay. So thank you.